Hi everyone, Quadian here. Chemistry with Quadian, it's our channel for chemistry students from all over the world. We will teach you every day about all of chemistry theory lessons. Subscribe our channel and press the bell button for daily lectures updates.
Dear students, Assalamu alaikum. Today we are going to discuss nomenclature of unsaturated hydrocarbon, which is known as alkyne. We will discuss all the important points which should be kept in mind while giving systematic name to the alkyne. So dear students, we know that the general formula of alkyne is CnH2n-2. And we know that n is an integer. When the value of n is 2, the value of hydrogen would become 2, thine. So students, now we will discuss the 6 important postulates which should be kept in mind while giving systematic name to the alkene. So first important postulate is the longest continuous chain which should include the carbon-carbon triple bond is selected. Our first important task is that we should select the chain which contain a carbon-carbon triple bond. So that would be our parent chain. Second important point is that identify and name the substituents. This is the most important point while assigning the nomenclature of alkane, is that our first target is that we must identify the substituents, that how many substituents are present in the parent chain. And after identification of the substituents, we should assign the name of the substituents. So this is the second important postulate while assigning the IUPAC name to the alkyne. The third important postulate is that the position of triple bond is shown by numbering the alkyne so that minimum number is assigned to the triple bond. So our third important task is that we should assign the position or a numbering to the parent chain, and we should assign the numbering to the parent chain in such a way that the triple bond should get the minimum possible number. So our target is that we should assign minimum possible number to the triple bond. So let's move towards fourth point. List the numbered substituent before the parent name in alphabetical order. So this is also the most important point, that we should assign the substituents in alphabetical order. For example, ethyl comes first and methyl comes later. We know that ethyl starts from E and methyl starts from M. So that's why when we write the name of the IUPAC name of the alkyne, then ethyl would come first and methyl would come later. So fifth important point is that carbon-carbon triple bond locant is placed either just before the parent name or just before the -ene suffix. So this we can write the name of alkane in two ways. So first way is that we can write the name of the before the parent name or just before the -ene suffix. So sixth important point is that if double and triple bond are present in a compound, then ending n-ene-n-yne is given to the root. For example, if both double and triple bond are present in a compound, then our target is that we should first assign -ene alkene. We first assign a name to the alkene, and after that we will assign the name to the alkyne. So now after thoroughly discussing these 6 points, now we will discuss all these 6 points with the help of examples. So first point is that identify the parent chain which should include the carbon-carbon triple bond. Our target is that we should identify the parent chain which include the carbon-carbon triple bond. For example, here it's contain 1, 2, 3, 4, 5 carbons. So its name is pentane because all the bonds are single. So here we'll start from this numbering from this 1, 2, 3, 4, 5. It's a alkene. We know that it's alkene. So its systematic name would be 1-pentene because it contains a double bond on one position. So here it is 1, 2, 3, 4, 5. It contains a triple bond on one position. So its systematic name would be 1-pentyne. So our target is that we should include the longest chain which contain a carbon-carbon triple bond. So let's discuss another example. Here, the longest chain contain 8 carbon, 1, 2, 3, 4, 5, 6, 7, 8, and it contain a substituent which is known as ethyl group on carbon number 4. So its systematic name would become 4-ethyl octane. Now we will discuss this example. The longest chain is 1, 2, 3, 4, 5, 6, 7, 8. Longest chain contain 8 carbon, but it does not contain carbon-carbon triple bond. So this could not be our longest chain. So our longest chain would be this 1, 2, 3, 4, 5, 6, 7. So this would be our longest chain because our criteria is that the parent chain should contain the carbon-carbon triple bond. So this could be our parent chain and this could be our substituents. So its systematic name would become 3-propyl, and we know that this is a propyl substituent, 3-propyl heptine. So identify and name the substituents, which was our second point. So here we discussed that this is our substituents. So its correct name would become 3-propyl heptine. So move towards third point. Assign a locant to each substituent giving the carbon-carbon triple bond the lowest possible number. Our target is that we should give carbon-carbon triple bond lowest possible number. For example, here is a structure. When we write this structure from left side, 1, 2, 3, 4, 5, 6, 7, the longest chain contain 7 carbon. So it must be, or it should be heptine. But as it contains triple carbon-carbon triple bond on the carbon number 2, so it is a correct structure, it is a correct numbering. Well, we assign the same structure from right side, 1, 2, 3, 4, 5, 6, 7. It is an incorrect numbering. Why it is incorrect numbering? Because here triple bond is getting the number 5. So our target is that we should assign carbon-carbon triple bond the lowest possible number. So this numbering is correct while this numbering is incorrect. So the position of triple bond is shown by numbering. We have given numbering to the position of triple bond. So the minimum number is assigned to the triple bond. So we have assigned minimum possible number to this triple bond. So 4 important points: list the numbered substituent before the parent name in alphabetical order. Our target is that we should assign the substituent in alphabetical order as we discussed earlier. Ethyl come first and methyl come later while assigning a systematic name to the alkyne. So 5th important point is that carbon-carbon triple bond locant is placed either just before the parent name. We can place the carbon-carbon triple bond before the parent name or just before the "-ene" suffix. So let's discuss this point. For example, here it is a compound. The longest chain contains 6 carbons, so it should be or must be a heptine. So it contains a substituent methyl, 2 methyl on carbon number 5 and 1 methyl on carbon number 6. So as we know that we assign substituent name first. So its correct name would be 5,5,6 trimethyl. 5,5,6 tri because it contains 3 methyl. Trimethyl and 2 heptine because 2 carbon contain carbon-carbon triple bond. So its systematic name would become 5,5,6 trimethyl 2 heptine. So we can assign also a second method to assign this. To assign the systematic name to this compound is that 5,5,6 because we know that we should assign the name of substituent first. So 5,5,6 trimethyl hept. Why hept? Because the parent chain contain 7 carbon. Hept and 2 position contain a triple bond, so hept 2-ene. So there are 2 methods while assigning a systematic name to the alkene. Both are discussed here. Hope so you get this point. So the 6th important point we should be kept in mind while assigning the IUPAC name to the alkene. If a double and a triple bond are present in a compound, then ending n-ene is given to the root. For example, if we have a double and a triple bond, then ending n-ene is given to the root. Lowest possible number is assigned to a double or a triple bond irrespective of whether "-ene" or "-ine" gets the lower number. It means that we should assign a lowest possible number to a double or a triple bond irrespective to whether "-ene" or "-ine" gets the lower number. For example, here is a compound, longest chain contain 1, 2, 3, 4, 5 carbon. if we assign the numbering from here, from left side, 1, 2, 3, 4, 5, the carbon-carbon double bond is getting a number 1. But if we assign numbering from here, 1, 2, the carbon-carbon triple bond is getting numbering 2. So our target is that we should assign the double bond or triple bond lowest possible number. So we will assign numbering from here. This is a correct method of numbering from left side, 1, 2, 3, 4. So 5. So the parent chain is contain 5 carbon. So its correct name is, as we know that we should assign the name of alkene first and alkyne later. So 1 pentene and 3 position contain a triple bond, so 3-ene. So here the systematic name of this compound would become 1 pentene 3-ene. So now discuss this example. 1, 2, 3, 4, 5 longest chain contain 5 carbon atom. We can, if we assign the numbering from here, from left side, 1, 2, 3, 4, 5. The carbon triple bond is getting number 1 and double bond is getting number 3. But if we assign numbering from here on the right side, 1, 2, the carbon-carbon double bond is getting numbering 2. So our target is that we should assign lowest possible number to double or triple bond, irrespective of whether ene or yne gets the lower number. So the correct name of this structure would become 3-pentene. As we know that we should name the name of alkene first and alkyne later. So the 3 position contain a double bond. So 3-pentene and 1 position contain a triple bond. So 1-ene. So a systematic name would become 3-pentene 1-ene. So it's in case double and triple bonds are present at identical position, the double bond is given the lower number. Suppose if both double and triple bond are present on the identical position. For example, select this longest chain, 1, 2, 3, 4, 5. This longest chain contains 5 carbon. If we start numbering from here, this alkyne will get number 1. And if we get numbering from here, this double bond get number 2. So in this case, when both the double and triple bond are present at identical position, the double bond is given the lowest number. So we should give priority to the double bond. We should neglect the triple bond here. So we will assign numbering from this side, 1, 2, 3, 4, 5. As 3 position contain a substituent which is methyl, so its systematic name would become 3-methyl 1-pentene, as discussed earlier. When double and triple bond are present, we should write the name of alkene first and alkyne later. So 3-methyl 1-pentene, 1 position contain double bond, and 4 position contain triple bond, so 4-ene. So it is the correct name of this compound. When we have a double and triple bond on the identical position, then we will give priority to the double bond. So common name derived from acetylene are often used as well. So there are some also common name of alkyne. For example, derived from the acetylene. For example, this is a acetylene. We know this is a acetylene and it is a methyl group. So its common name methyl acetylene. We can also write this methyl acetylene. So this is also the second common name is this is a propyl group and this is also a propyl group, as this contains 2 isopropyl groups, so diisopropyl acetylene. The third example important is that here is a acetylene. So phenyl, this is a phenyl and this is a propyl. So this is a phenyl propyl acetylene. So this alkynes can be numbered by this common name derived from the acetylene derivative. So alkynes are also classified as a terminal or an internal alkene. What are terminal? If the triple bond is present on the terminal position, then it is a terminal alkyne. If triple bond are present in the middle of the carbon-carbon bond, then it would be a internal alkyne. So students, that's all today's lecture. If you like our videos, kindly subscribe our channel and remember me in our prayer.